Okay everyone, today we want to learn about three-phase diagram. Three-phase diagram is a soil model. So from this soil model we can translate to soil properties and of course more equation based on that soil properties. So I hope that you have pencils and paper in front of you, so let's do this together. So in three-phase diagram, if we consider as a soil in the container, so this is your soil in the container, we know that inside this soil you have soil in terms of solid element, and then you also have water, and then of course you have air. So we need to translate all of these three elements into three-phase soil diagram. Okay, what you can do is to draw like this, and then we will segregate all the elements based on its density. The dense portion or the dense element, we will put it at the bottom of this three-phase diagram. The intermediate is less density, and the upper part will be the most light or the most value in terms of density. So if we know that we have the element of air, water and solid will take the lowest part, water will be at the intermediate portion, and this one will be air. Okay, this when you will ask about what is three-phase diagram, this is the soil diagram that you can draw. But apart of this, we want to know a lot more which equation that represent for this particular three-phase diagram. Okay, before I introduce you to any equation for this three-phase diagram, let we learn about the notation. So if you see this air will be represented by air A, water is W, and then solid or salt it will be presented by S. Okay, at the right hand side, this is where we will put our volume equation, and at the left hand side, this is where what we want to put our mass equation. Okay, so let's from whatever we have done right now, okay, we want to see if this is your air, and then we present mass in terms of m, so your air will be ma, and then the same thing for water, mw, and then for solid that will be ms. Okay, let's say they ask you, can you calculate what is the total mass of this soil sample? Of course, total mass will be m total is equal to ma plus mw plus ms. Okay, let's do this for volume part. So in this portion, you have notation of VA to indicate that will be the volume of your air, and this part will be VW, volume for water, and this part will be Vs, that will be the volume for solid. Okay, other than this three-phase diagram, okay, the things that you also need to know is about void. Void is volume of water plus volume of air, and that is notation we put is VV, or volume for void. So for if you want to note at the bottom here, VV or volume of void is equal to, sorry, it's kind of VA plus VW. Okay, this will be the basic principle of what you want to know about three-phase diagram. This is only the notation given to all of you. Okay, but all of this is representing by its own equation. So let's do this together. Okay, for volume of soil or volume of solid, Okay, the value we will use 1. Okay, we always value the volume of solid or soil as equal to 1. And then you have a void. Void is equal to E, and this E is actually void ratio. Okay, I know that you will question what is void ratio because you never heard about a void ratio. We will define what is void ratio later on. But right now, for three-phase diagram, I need to introduce to all of you what will be all of this notation representing with equation, so that when we define all of the definition, you can use this equation to form your required equation. Okay, for VV, okay, I just read it, I write it right here. Sorry, this is VA, volume of air. Volume of air is representing by the equation of E 1 minus SR. Okay, E is void ratio, SR is equal to degree of saturation. Okay, don't worry very much right now for all the terms that you still not know, because every of these term we will define later and we show you how to calculate for it. So for this portion, this is volume of water. Volume of water is given by SRE, meaning that degree of saturation multiplied by void ratio. And volume of water also can be represented by the equation of WGS. Okay, other one. You will use either this equation SRE or WGS if required in your equation letter. So whenever possible you use it. Whenever suitable you will use either one. And then for volume of solid, okay, we don't have anything to represent the value of volume of solid except what we know earlier as 1. Okay, that is for volume. But right now we want also to learn about mass. Okay, for three-phase diagram, for mass of air, okay, we know that air will not take any of mass value. We cannot weigh your air, so it always give the value of 0. And then for mass of water is given by WGS rho W. Okay, this is the equation that you need to remember. W is water content, GS is specific gravity or particle density, and raw water is density of water. And the last notation that you need to know is mass of solid or mass of soil, that is given by equation of GS rho W. Okay, the tips for this three-phase diagram. But before that, I think you need to jot down all the notation so that you can remember. W is equal to moisture content, and then GS is specific gravity, and then you have rho W is equal to density of water. Okay, later on, you also will find rho S, which is density of solid or density of soil. So, at this point, I hope that you can replicate this three-phase diagram with all of its notation and equation. So this part is volume of air, this part will be volume of water, this part will be volume of solid. Air and water we also known as V or void, and then your void is represented by the value of E or void ratio. So solid will be take number 1, the value 1. And then please memorize all of this equation. VA is equal to E in bracket 1 minus SR. VW is equal to SRE or WGS. And also for the part for mass. Okay. Hopefully you all can draw this. The most important is for you to remember all of the equation and three-phase diagram.